Okay, let's look at a few more examples of solving a quadratic by factoring. So this is the first of our three methods that we're going to use to solve quadratics. So in the first one, we just want to make sure that this is in standard form and equal to 0, so it is. So we're going to factor out a common factor of 2x. Make sure you carry the equal 0 along with each step. That's just really good communication and notation. Dividing out a 2x, we're left with x minus 10. Then we're going to set each factor equal to 0 and solve for x. So the first one, dividing by 2, 0 divided by 2, we just get x equals 0, and our second solution is x equals 10. Let's go down and talk about a little vocabulary before we do the next example. So you'll notice that I have the 2x squared minus 20x here and 2x squared minus 20x here. The first time I've written it, I have it equal to g of x. This is a function. I've named this function g of x. So when we set that function equal to 0 and solve it like we did above, that tells us where the graph crosses the x-axis. So we are going to call those x-intercepts. So the work that we did above gives us the x-intercepts, and another name for x-intercepts is zeros. So we would write those x-intercepts as 0, 0, and 10, 0. So again, if we have a function with a name, like g of x, and we set that function equal to 0 and solve, we call the answers x-intercepts or zeros, because g of x is a function. On the right, if we have an equation, if we have that 2x squared minus 20 equal to 0, that's an equation, so slightly different. So this guy, he doesn't have a name. We don't call him like f of x or y or g of x. He's an equation. We're going to call those solutions or roots. When we solve that equation, or when we solve the equation, we call the answers solutions or roots. So our two solutions were x equals 0 and x equals 10. So we did the same math to get there. We factored and we set each factor equal to 0 and solved, but it's just the answers have slightly different names. Let's go ahead and do the one above. Now the key thing to keep in mind is we want to factor out a common factor first, and we're left with x squared minus 2x plus 1. And then doing product sum method, we need two numbers that multiply to 1 and add to negative 2. Well, the only integer factors that 1 has is 1 times 1 or negative 1 times negative 1. And so they're both going to be equal to x minus 1. So when we solve this, if we set 2 equals 0, that does not give us any solutions. And then solving, we get x equals 1. So this guy only has one solution. You can write it twice, or you can write it once. Okay, when we solve a quadratic equation, we need to get it in standard form. So what form do we need to get it into? We need to get it in standard form. So what standard form is ax squared plus bx plus c equals to 0. Okay, so first example here, we need to move the 21 over to the left to get it in standard form. Now you always want to move the term so that the x squared stays positive. Or if the x squared is negative, you want to move it so it becomes positive. Okay, so we're going to factor this by product sum method, x minus 7, x plus 3. Now we set each factor equal to 0 and solve, and I'm going to do that mentally. So if I were to take x minus 7, set it equal to 0, I would solve and get x equals 7. Same thing here. If I were to take x plus 3 equals 0 and solve, I would get x equals negative 3. Next one is not in standard form, so we need to move that 3x to the left first, and then factoring out the greatest common factor. Again, we set each factor equal to 0, so setting x equals 0. When we take the next one and set it equal to 0, x plus 3 would equal 0, so x would equal negative 3. Okay, and lastly, we're going to solve this in the graphing calculator. So what we're going to do is, in a second, we're going to go to our graphing calculator and type this in for y1. So x squared minus 6x minus 14, and I got to this screen by hitting the y equals button below the screen. So now going to our graph, we're looking for the x-intercepts. So we're going to do second, trace, and the x-intercepts are also called zeros, so we're going to select option 2. Now we want to move the cursor to the left of that first x-intercept. So see my cursor is right there. I'm going to hit enter. Move the cursor just to the right of that x-intercept, or a little bit further to the right, it doesn't matter. As long as you only have one x-intercept between the left and the right bound, it doesn't matter how far to the left and how far to the right of it that you go. And on the TI-84 calculator, you'd have to hit enter one more time to get the x-intercept. So our 0 is at negative 7.95 or negative 1.796. So our x-intercepts are negative 1.795. So we want to do 3 decimal places, or negative 1.796. So in AP Math, you need to do 3 decimal places in your answer, and you can round it to the nearest thousandths, or you can just truncate it and stop writing numbers. Okay, let's go back to our calculator and get the other x-intercept. So we're going to, again, do second, trace, and then number 2 is 0. So I can see my cursor, and I'm going to hit the cursor to the right. Now below the screen, those numbers tell me where the cursor is. So I just kind of keep track. The cursor is way down at a y value of negative 20 right now. So I'm going to keep going until the cursor shows back up, which should be right around now. It's currently to the left of the other 0, so I'm going to hit enter. Tap it over to the right a few more times and hit enter. And it gives me the 0 below the graph is 7.795 or 7.796. Okay, so interestingly, these gave me the same decimal values. That's not always going to be the case. Let's go ahead and write down the steps. So we're going to input function into the y1. And then once you're on the graph, you're going to do second, trace, and option 2. Then you're going to hit the left arrow. So there's a left arrow button until the cursor is left of one of the x-intercepts. And hit enter. Then you're going to hit the right arrow until the cursor is to the right of the x-intercept and hit enter. And then on the Calculate 84 app, that will then give you the x-intercept. On the TI-84 calculator, you need to hit enter one more time.